Okay, let's talk about the bag of words today. What do we need the bag of words for? I will give you a little example, and then we're going to build a small sentiment analyzer with a neural network based on movie reviews. So let's dive right into it. Let's start with an easy example. Let's take two sentences. And the weather is bad today. Now we would apply the basic steps we learned in the last video, tokenization and stopword removal. Let's do it. So if we remove the stopwords, what will basically be this is A and the is yes. And the bag of words is basically a matrix representation where the rows are each sentence and the columns are each word in the vocabulary. Bad, example, and today, and weather. So here we have sentence 1, sentence 2. Now just the word count in those sentences. So we have bad, example, nothing of them. And here bad, 0, 1, 1. So why do we need this? Because a computer or a neural network can't understand words by themselves, of course. It can only do mathematical operations, so we have to convert the words into vectors. And if you would feed the neural network now with this bag of words, you can think of each column as one feature. So, and then we would have the label, good or bad, since we're talking about sentiments here. In this case, both sentiments would be bad, so we have 0 and 0. To put it in statistical terms, the features are the independent variables with which we want to predict the label, which would be the dependent variable. But don't get encouraged about those statistic terms, just think about the basics here. Which words would lead to the specific label? Just simply put it this way. If we would have another word here, good, and just for example, the second sentence would look like this. We would have good in the word, then the label would be positive. And the neural network would now compute which of these words would have the most influence on the sentiment. Obviously here the word good would influence the label to be positive or the sentiment to be positive, and bad, the bad sentiment. This is very simplistic, but you get the idea. Also, if a sentence would contain the word more than once, for example the word example, then we would have a two here. So it's just a representation of the counts of words in each sentence. Now let's actually do it on a real data set and train a model. Okay, so we first need to install some requirements. We will need datasets from Hugging Face, NLTK as before. Also we will work with pandas and Scikit-learn, which will have the neural network. Okay, let's install it. Import NLTK. From dataset, let's import load dataset, also import pandas as PD and import numpy as NP. Perfect. Where's the dataset coming from? Here from Hugging Face. Hugging Face is an open source platform. They have lots of pre-trained language models and datasets. We want to train a sentiment analyzer on movie reviews. Let's look for Rotten Tomato movie reviews. The dataset basically looks like a text column and then the label, positive or negative, 1 or 0. So the dataset has different splits, the train, validation and test split. You use those splits for the train, obviously, to train the model, and the validation split is to, while training the model, you will validate that the loss function, if you just train long enough, or if your neural network is really big, then it could actually mesmerize the data, so it wouldn't be able to generalize and predict on not seen data. This is called overfitting, and we want to prevent overfitting. Therefore, we have a validation set, so the model can, well, after a couple of training steps, it will validate and see if the loss function also decreases on the validation data, which is not seen in training, so unseen data. And if the validation score also gets better, then it keeps training. And at that point, when the training score is getting better, but the validation score stays the same or even gets worse, then we know, okay, we reached a point where the performance is not getting better on generalization, so we have to stop the training here. It's just called early stopping. Here a simple graph. The epochs are the iterations of training, so how often the model sees the training data, and then you have the loss value on the y-axis. As you can see, underfitting is the point where the model isn't trained good enough, so the score could still get better, which might also happen if your model is too small, so it can't grab the complexity of the data set. Then you would have to increase the number of hidden layers or the number of neurons. And a good model would be somewhat here in the middle, where you have where the validation error and the train error are near another, and you can see if the overfitting point will start where the training error will increase. The error will increase. The error will decrease slightly, but the validation error is increasing because the model is just mesmerizing the training data but can't generalize on new data. Train dataset would be load dataset, Rotten Tomatoes, train split, test data, and validation data. Here we want to use the pandas data frame to put the data in the table. So train data frame, basically pandas data frame, and the same for test and validation. Now let's look at train data frame.head, which will show us the first 5 entries. And we also want to change the settings so we can see the whole column. pd.set options, display max column width, and there we have it. Okay, now we want to clean the text. So we will write a pre-processing function which will remove everything that are not letters. We will lower the text, but it seems like it's already lowered. But just in case, since we didn't saw the rest of the data set, then we're also going to remove the stop words. In this case, we're working with sentence tokens. So we'll keep everything as a sentence, but cleaned. Okay, letters only if you regex, and this basically means remove everything that's not letters and replace it with a space. Tokens will be, we will lower the sentence and then also tokenize it with the NLTK library. We also need to import the stop words from NLTK corpus import stop words. Stop words, will be the set from the English vocabulary. Return a token for every token in tokens if the token is not in stop words. Now we want to join all the filtered words together and we'll have a clean sentence. Let's just look at the example. Pre-processing of train data frame and the first text. As you can see, we have no more numbers, no more points, commas, everything got removed. Now we want to apply it on the whole data frame. Train data frame, cleaned, then point apply. And with the apply function, you can apply a function, or you also could define lambda x and define here another function. For the bag of words model, we now want to use Scikit-learn. We're going to take the count vectorizer. It will convert the collection of text documents to a matrix of token counts. That's what we need right now. From Scikit-learn feature extraction by text import count vectorizer, count vectorizer, just the basic version. It has some different functions. We want to fit it, basically train it with our corpus of text, and then also transform the text. You could also call it separately. You could fit the vectorizer and then take the vectorizer to transform the text separately. But they have a function to do it all at the same, so perfect. We also want to convert it to a NumPy array, so to array. Now let's look at the train features. Let's also set the NumPy, set the print options and threshold with infinity, so we can see the whole array. Oh wait, let's just look at the first item. And here you can see, obviously there are a lot of zeros because one sentence has, I don't know, like 15 words or something. You can actually check it. Okay, it would have 19 words in this case. Yes. So there are a lot of columns which are all our words. Let's actually check this out. Train features, shape. Yeah, we have 8,530 sentences and 16,165 words. This sentences should be also the same amount as in our data frame. Train df and shape. Yes, 8,530 sentences. You want to use a neural network, and we need a multi-layer perceptron classifier. The regressor would be to infer numbers, but we want to categorize it into basically into two categories, bad or good. And therefore we need a multi-layer perceptron. And what a perceptron is, what a multi-layer perceptron is, I will explain in another video. But basically, what is explained short, a perceptron is one cell where calculation happens, and a multi-layer perceptron would be, you have multiple perceptrons in layer, and you would also have multiple layers. So from Scikit-learn, neural network about NLP classifier, and the NLP classifier, let's try it with just one layer. And also alpha is the learning rate, how much to update the weights of the network. We want to fit the model, put in the train features and the label. And this might take a little while. Let's prepare the test prediction. So in this case, we only use transform. This might mean that if in the test data frame we have some words which weren't seen before from the vectorizer, which we fitted on the train dataset, these words would not be considered, so we would not have them in our vector in the end. Test results would be like perceptron predict test features. Output data frame be under data frame. Text from the test data frame was the labels from the test results. As you've seen, the training took 2 minutes, but the prediction didn't even took 1 second. From Scikit-learn, metrics about the accuracy score, I want to see how good our model performed. 75%. It got 75% of the sentiments correct. Let's see if we can make it a little bit better if we increase the layer size. So now we would have 3 layers with each 100 perceptrons. And you can also play around with the learning rate, but I will just keep it at this. In general, if you're working with large datasets, large models, you would use a GPU for parallel computation, and the trainings could take hours, days, weeks. GPT-3 training took already 34 days and costs 4.6 million with 1024 GPUs. Now let's see how the 3 layers will perform, and now 78, so it got better. Let's try some sentences for fun. Point predict, want to see the probability of count vectorizer transform. It's a function. What's the function called? Preprocessing, of course. This movie was not bad. It's first. This movie is bad. So the model interprets the sentence with a 99 probability of bad sentiment, 0.1% of good sentiment. Okay, let's try. This movie is not bad if it gets that. It did not get that. Okay, here's the problem because of the stop word removal. This is a disadvantage of this back of words model because it can't get the semantic perfectly right of the sentence. The movie was good, but it smelled like fuck. Uh-huh. Okay, overall it's fine, but if it's not fine overall, it's bad. interesting. Let's take a look at the actual data set to see where the word comes into play. Want to filter the training data set by training data like text contains fart, and let's output it. List object is not not training data frame, of course. Dumb fart jokes. So you can see we have a lot of sentiment where the people are complaining about dumb fart jokes. So in general, the model combined the word fart, more of a negative sentence. If you think about it, we didn't apply stemming, so this sentence would, this word would not be considered, and you would only have, those negative sentiments. So basically, the model mapped the word fart only to a negative sentiment. The vectorizer gets feature names out, and if we search for it, you can see. I'm interested now if the stemming would change something at the score. We can add it to the preprocessing. Let's look at that. Let's try it out. Preprocessing learning. Yes, let's do it again. It actually got worse. Okay, sometimes you have to play around. Sometimes it depends on the data set, it depends on the context. As you can see here, it did not help us to stem the words. That's okay. To conclude the back of words session, what are the advantages and disadvantages? The advantages, it's easy to use and also very simplistic. So in this short time, we just trained the model on the sentiment with a score of 75% or 78, it's scored before, which is not bad, it's okay. The disadvantages are back of words is bad at big data sets because, as you saw, you have one column for every word in your corpus, and you will have a lot of zeros and just a few ones. I mean, I don't know, 20 depends on the sentence length. And that's not pretty good input for a model. There are better methods. Also, another drawback would be that we don't have weight or importance on the words themselves. It's just the word count, and in most cases you also only have a one in the sentence. The word only occurs once. So that's a drawback. And there are methods to solve these problems. TF-IDF, word2vec, or we will see what else we have to combat those problems in the next videos. And I hope you liked it, you could learn you could learn something out of it, and subscribe and see you in another video.